Miniaturization of PCBs refers to the process of designing and manufacturing smaller and more compact printed circuit boards, while still maintaining the same or even higher level of functionality. This is achieved through a combination of advances in materials, manufacturing techniques, and design methodologies. The benefits of miniaturization in PCB design are numerous. Smaller PCBs can reduce the overall size and weight of electronic devices, making them more portable and easier to integrate into other systems. Additionally, smaller PCBs can reduce the cost of production, since they require less material and can be manufactured more efficiently. There are several key techniques and technologies that enable miniaturization in PCB design. Surface mount technology, SMT. SMT is a method of attaching electronic components to a PCB, where the components are placed directly onto the surface of the board rather than being inserted into holes. This method eliminates the need for large holes, making it possible to create smaller and more densely packed PCBs. High-density interconnect, HDI. HDI refers to a set of techniques for increasing the density of connections between components on a PCB. This includes using smaller vias, thinner traces, and other design optimizations that allow for more connections in a smaller space. Microvias. Microvias are tiny holes drilled into the PCB that allow for connections to be made between different layers of the board. By using smaller vias, it is possible to increase the density of connections and reduce the size of the board. Advanced materials. Advances in materials science have made it possible to create thinner and more flexible PCBs, as well as materials with higher thermal and electrical conductivity. These materials enable designers to create smaller and more complex PCBs. Multilayer PCBs. Multilayer PCBs consist of multiple layers of copper and insulating material, allowing for more connections and higher component density. By stacking more layers, it is possible to create smaller PCBs without sacrificing functionality. Overall, miniaturization in PCB design is driven by the need for smaller and more portable electronic devices, and is made possible by advances in materials, manufacturing techniques, and design methodologies. By leveraging these technologies, designers can create smaller and more complex PCBs that meet the demands of modern electronics.